Today, let us talk about hydrogels in agriculture. As you all know, in crop production, the most limiting factor is water, which is lost through evaporation, deep percolation, runoff, etc. Especially, it is the most limiting factor in dryland areas and in drought-prone areas. So, in those conditions, this hydrogel provides a boon where it absorbs water and supplies water to the plant under water stress conditions. How does it do so? Let us discuss in briefly. Hydrogels are also called as superabsorbent polymers. These are the soil amendments which are added to the soil so that they can absorb large amounts of water and retain and give water to the plant whenever drought prone conditions or water stress conditions. They improve water retention and irrigation efficiency and crop growth. Especially they are used in sandy soils and light texture soils. They reduce water loss through runoff, they reduce erosion, they reduce deep percolation losses, they increase nutrient availability and nutrient retention in the soil, and they also provide higher soil microbial activity. So their effectiveness depends upon type, means what type of hydrogel you are going, whether it is synthetic or natural, and application rate, how much you are using, or at what dose you are using, and what condition you are applying, whether it is dry condition or wet condition. And always remember, excessive usage may reduce soil porosity and gas exchange, as it may block the soil pores. And the specialty of superabsorbent polymers is they are mostly biodegradable nature. They degrade under sunlight and oxidation conditions. Because of this, they are not going to harm any soil health. They doesn't harm the soil health, soil microbes, because they are naturally degradable. This is classification of hydrogels. You can notice here based on origin, polymer composition, configuration, physical structure, cross-linking method, responsiveness, and degradability. And these are different classes based on natural hydrogels, synthetic hydrogels, based on physical structure, macroporous, microporous, less than 50 nanometers, greater than 50 nanometers, based on degradability, degradable polymers, non-degradable polymers. So this is the different classification of hydrogels present in the literature. So how hydrogel holds lot of water. So this is hydrogel in a dry state. You can note this is the polymer chain. These are cross-link points. So this is in a 3D network. So whenever water enters the network, whenever these water molecules enters into the polymer chain, this polymer will attract the water. This polymer will have hydrophilic groups like OH, COH, NH2. And these water molecules will be attracted by this hydrophilic. Hydrophilic means water loving groups, and they form hydrogen bonding. This hydrogen bonding is something permanent in nature. So hydrophilic groups on the polymer attract these water molecules through hydrogen bonding. Afterwards, this hydrogen will swell and they hold lots of amount of water. This negatively charged groups inside the polymer will create osmotic pressure. This osmotic pressure makes more amount of water enter into the hydrogel, and so that this hydrogel will be swelling without dissolving. This is how hydrogel holds lots of water in its body. Example, this is hydrogel, dry hydrogel. After entering in the water, it becomes swollen 200 to 1000 times of its own weight in water because of swelling of its polymer chains. Let us imagine a dry net. So this net is empty. When you put it in the water, what happens? This net holds lots of amount of water. Otherwise, you can also assume a sponge. Whenever you're dipping the sponge in water, this water molecules enters into the space in the sponge and they are able to hold lots of amount of water, 100 times of its own weight. That is how this hydrogel holds lots of amount of water because of its hydrophilic groups present in its polymer chain, and because of the osmotic pressure, this will be swollen and the water will be trapped inside the hydrogel because of the strong hydrogen bonding. So hydrogel, when it is dried and conditioned, the water what he applied is absorbed in between the polymer chains. Hydrogel absorbs water through its hydrophilic groups and swells. So how does it give back to the plant? So after absorption of water, again when the soil is in dry condition or whenever the plant notices water stress conditions, what happens? The soil what is there has lesser water potential when compared to the hydrogel. Since hydrogel have more water, which is trapped into the 3D network or in between the polymer spaces, it will be having higher water potential and the soil will be having lower water potential. So always remember the water moves from higher water potential to lower water potential. Now higher water potential is in the hydrogel, lower water potential is in the soil. So the water will be moving from hydrogel to the soil. Afterwards what happens? This hydrogel will shrink because it loses water. So imagine a condition, dry hydrogel, rain has occurred or you have given irrigation, it has swollen by absorbing water in it and stores water in between the polymer spaces because of the hydrogen bonding. Now the soil became dry. Because of this dryness, the water moved from hydrogel to soil because of water potential gradient, that is from higher to lower. Now water released by the hydrogel shrinks, but the water which is present in the soil will be absorbed by the plant. So always remember, in case of release of hydrogel, you have to remember it is water potential gradient which is helping the water to move from hydrogel to the soil, from soil to the plant. The polymer network which is holding water in the hydrogel, but it is not permanent, and because of the diffusion process, the water molecules move slowly in the polymer network, and because of the pores where hydrogen channels, water moves through the tiny pores in the hydrogel. So hydrogel is something which is able to store water to 100,000 times of its own weight, and it acts like a reservoir. So reservoir, it stores water. When there is stress, it is giving water to the adjoining area. Similar fashion, hydrogel stores water, and where is stress, it gives water to the plant to for its improvement. So application of hydrogel. Hydrogel is something a water retention material or a soil absorbent. It absorbs water and releases water slowly to the plants. It should be applied in the root zone or actively growing root zone. So at the time of sowing, what you are going to do, you are going to take recommended dose of hydrogel, you are going to mix it with the soil and you are going to place in the root zone or transplant near the root zone, and you are going to irrigate afterwards. Or in case of established plant, you are going to make hole near the plant and you are going to place the hydrogel in the holes where you have made it, and you are going to cover it with the soil. Always remember, you should not directly expose this hydrogel to the direct sunlight. So this is the recommended dose, 3 to 10 grams per plant in case of vegetables. In case of rice, it is 2 to 5 kg per hectare. In case of fruits, it is 5 to 20 grams per hectare. Based on the plant, based on the phenology, based on the type of soil, it will be varying from condition to condition, situation to situation. In case of trees, it is 20 to 100 grams per tree as a basin application. You are going to make holes in case of established plant. At the time of sowing, you are going to mix in the soil and you are going to apply. Where you are going to apply 0 to 5 centimeters if it is for surface application. Most recommended is between 5 to 15 centimeters. This is the ideal place for hydrogel application. More than 15 centimeters below root zone is not so much effective, as roots cannot take the water which is released by the hydrogel if they are placed at very deep. This is how water is uptaken, stored and released by the hydrogel. So these are the precautions. You should not apply on the soil surface because it is of no use. It will be evaporated directly into the atmosphere. Mix well and apply in the root zone, that is also an active root growing portion. Follow recommended doses. Avoid mixing with fertilizers or chemicals as it may react or clog or it may form clumps near the root zone. Avoid direct sunlight or store in a cool place. These are the different strategies for application of hydrogen in the field. So this is dry method of hydrogel application where you are applying dry hydrogel directly into the field. This is mostly used in case of field conditions. Whenever rain comes or whenever you are going to irrigate the field, then the hydrogel will be absorbing water and going to swirl, and it is going to supply water when dry conditions prevail. This is wet method of application of hydrogel where you are making hydrogel to swell before applying itself. Before applying itself, you are going to swell the hydrogel. Afterwards, you are going to apply to the field. It acts as an instant reservoir of water supply to the plant. Use of hydrogen in various irrigation systems. This is in case of drip. This is in case of furrow. This is in case of deficit irrigation system. Deficit irrigation system means water is already less in this condition. So in this condition, usage of hydrogel is very much recommendable and recommended. So usage of hydrogel improves moisture, as this hydrogel when it is applied to the soil, it absorbs water and it swells and provides water to the plant when it is drier and condition. Along with that, the hydrogel will be automatically degradable if it is natural. If it is synthetic, it takes a little bit longer in time. And along with that, it also stores nutrients. Whenever it releases water, these chains will be broken down, and these nutrients also released along with the water to the plant. So hydrogel seed coating will improve germination. So what happens whenever the seed is coated with hydrogel, this hydrogel will supply enough amount of water to the seed for its germination. So this water will be absorbed by the seed. This indicates or triggers the activity of gibberellins and other biochemical changes along with the moisture, ample amount of moisture, making the plant to germinate properly and establish properly because of the presence of hydrogel. Survival duration of incorporation of hydrogel, if you look at different soil conditions, sandy loam, silt loam, clay, and different concentrations of hydrogel 0.2%, 0.4%, sandy soil will have more amount of survival rate at both conditions 0.2 and 0.4 conditions when compared to clay soil, because clay itself can have lot of amount of energy to store more amount of water, whereas in sandy soil, because of the large macropores, it cannot store water. In those conditions, if you apply hydrogel, it will be more beneficial, and application of hydrogel in case of dry conditions is also more beneficial because it absorbs more amount of water, improves soil nutrient capacity, and give back to the plant in some similar fashion. Look at this experiment. This is calcium cross-linked alginate. This calcium is cross-linked in the hydrogel in order to provide stability under dry conditions. Along with that, it can provide calcium to the plant under drier situation. Afterwards, it is coated with melatonin. This melatonin is providing safety to the plant under stressful conditions by removing the reactive oxygen species. Alginate hydrogel seed coated with melatonin. What happens under salinity stress? The plant which is coated with hydrogel melatonin is tolerant, whereas the normal plant is sensitive and it dies. So this is a green study, means without adding any chemical, you are going to make the plant to be tolerant towards salinity. Calcium alginate based hydrogel seed coating contains melatonin, has provided a significant protection against salinity without damaging the plant. What happened under stressful conditions? The plant is able to produce hydrogen peroxide and MDA. MD is nothing but melanodialdehyde. This is a biochemical which is used to indicate oxidative stress. When it is produced more, it indicates oxidative stress. Along the same is the case with H2O2. Under stressful conditions, this content will be higher. Whenever this content is higher, then it causes the death of the cells because it produces reactive oxygen species. So whenever the seeds are coated with this melatonin under hydroprimed conditions along with the hydrogel, the reactive oxygen species will be suppressed by producing catalyzed soproximate dismutase, ascorbate synthetase, and catalyzed enzymes. This is able to suppress the activity of this melanaldehyde and hydrogen peroxide and making the plant viable and grow and tolerant to the saline conditions. Look at the different conditions of saline stress control 50 mm and 75, where you can find the hydrogel primed with melatonin has a significant impact when compared to untreated. This is a hydrogel along with melatonin coating on the seed is able to make the tomato plant tolerant to salinity by removing the reactive oxidation species produced by the peroxide, hydrogen peroxide and melodialdehyde, and able to make the plant susceptible if it is not biocoated and tolerant if it is biocoated with melatonin under hydrogel with calcium cross-linked alginate, which is greener in nature, which is green approach. Look at the contribution of hydrogel in soil and water conservation in dryland areas based on different research. It prevents soil compaction, improves soil aeration. It reduces erosion by about 30%. It increases water use efficiency and nutrient use efficiency. In sandy soils, field capacity is increased by more than 50%, and it also improves growth of microbes. It absorbs several hundred times of its own weight in water and supply that water to the plant under stressful conditions because of the water potential gradient and by root capillary suction mechanism. It stores micronutrients and also absorbs pesticides and decreases concentration of arsenic by 81%. It reduces water loss from evaporation, increases water use efficiency by 13% to 41% in sandy soils. It reduces heat stress by conserving more amount of water. It stores water and supplies that water to up to 95% of its weight of what it has stored under drought conditions. It increases soil structure and water infiltration rate in sandy loamy soils and increased infiltration by 25%. These are the different implications of hydrogel in dryland areas and in conservation of water that helps in saving water. Coming to challenges and benefits, to talk about natural hydrogel polymers, they are biodegradable in nature since the hydrogel which is prepared is from natural sources and it is bioavailable and they have large impact on soil properties as absorb water, maintain soil retention and increase soil porosity, etc. Coming to the challenges, they lack mechanical strength and they are sensitive to pH and temperature changes and they are difficult in preparation and inconsistent in performance. Whereas synthetic hydrogel polymers are having very good mechanical strength and long shelf life and their production is also very easy as they are synthetically made. But the major challenge we are going to face is they are non-biodegradable and they release microplastics and cause soil health pollution. And because of this microplastic in nature, they are lacking water solubility. These are the major challenges in case of synthetic hydrogel polymers. Therefore, application of hydrogel saves water as it absorbs and stores water and releases whenever necessary under drought-prone conditions. And it improves crop growth by improving nutrient use efficiency to the plant and supplying moisture to the plant and improving soil properties. And synthetic hydrogeels are a little bit concern as they degrade very slowly and release microplastics into the soil so that soil health can be disturbed. So instead of synthetics, you can go for application of natural hydrogeels which are made from chitons, celluloses, etc. Anyway, both synthetic and natural hydrogels will be degraded, but synthetic hydrogels will take long time to degrade, and their effects are not known and yet to be discovered. And hydrogels application with good agriculture practices will reduce the risk to the farmers and increase yield. Bio-based hydrogels are safer and a sustainable option for water-limited agriculture. Therefore, hydrogel application is a very valuable technique for reducing freshwater irrigation shortages and boosting crop production to improve soil health in arid and semi-arid areas. Finally, hydrogel, when a plant is suffering from water stress, when you apply, then the water is taken up by the plant and it grows properly. So these are the different references where we have taken and different studies.